Hello everyone, welcome to the session on pattern recognition. We saw in the earlier session about strong AI and weak AI. Strong AI is computers thinking almost at the level of human beings, whereas in weak AI, we are attempting to solve problems by detecting useful patterns. I also said this is the dominant mode of AI today. We are solving problems by identifying patterns, and from those patterns, we are trying to predict, we are trying to forewarn, we are trying to develop statistical models. So that's at the core of machine learning and what we are doing extensively in the world of artificial intelligence, right? As I said, this is the dominant mode of artificial intelligence. Hence, it is very important that you understand about patterns, right? What is a pattern? How patterns can be identified, and how patterns help to develop statistical models, develop forecasting systems is what you're going to see in today's session. This is a very important topic, something that is at the core of artificial intelligence and machine learning. This is John McCarthy. We saw that. He coined the term artificial intelligence in 50s. Okay, before everything, let's understand what is a pattern. You may or may not know this. A pattern is something that repeats in a recognizable way. It could be numbers, it could be images, it could be alphabets, it could be designs, right? All odd numbers, they get repeated. Even numbers, they get repeated, right? Every year, certain festivals come and they follow a pattern. Christmas comes in December. That's a pattern. New Year is at the beginning of the year, right? So that's a pattern. And certain things happen around those days. For example, sales actually increases around festival time. That's a pattern. That is something you use to develop your forecasting model. And sales decline during certain months, right? In months where there are no festivals, no specific activities happen, sales actually decline. That is also a pattern. And as machine learning and artificial intelligence professionals, it's important that you identify these patterns. Without this pattern recognition, it is not possible to develop statistical models or artificial intelligence systems, right? So a pattern is something that repeats itself in a recognizable way, okay? But pattern sometimes it's not easy to recognize, right? It's recognizable, but it's not easy to recognize. You have to take efforts, right? You have to pay particular attention. You have to sometimes stare at something for a long period of time before you can recognize it, right? That's a human way of doing it. Why are we covering this in artificial intelligence? In the realm of artificial intelligence, the machine or the software recognizes these patterns, right? And that's where this pattern recognition comes, right? And that's why I say that pattern recognition is at the core of machine learning and artificial intelligence. Your software programs are going to teach the software, right? Teach the machine to learn the patterns, right? So that the software can identify the same patterns in future, right? Why pattern recognition is important? Pattern recognition is important because once we identify the patterns, we will be able to identify the patterns in future, right? So this helps in forecasting, this helps in predicting, and this helps in preventing, right? So that's why pattern recognition is at the core, and pattern recognition is very helpful for machine learning, which is why we are covering this in this session, right? It's a consistent recurring characteristic that helps us to identify a pattern, a phenomenon, right? It is consistent and it is recurring, right? These two words, please remember it. It's consistent and recurring. Only then we call it as a pattern, right? As I said, some patterns are easy to identify, some patterns are difficult to identify. In machine learning, we are going to help the computer learn this pattern. Your software is actually making the computer learn this pattern recognition. This consistent recurring characteristic, what we call as pattern, is learnt. The process of identifying this consistent recurrent characteristic, okay, is taught to the machine, right? So machine can identify the patterns, spot the patterns, right? As I said, some patterns are difficult to spot, right? Human beings, right, may find it difficult, but computer may not find it difficult, right? If there are multiple variables, multiple factors at play, it is always difficult to identify a pattern. That's where software comes. That's where machine learning helps and makes a big difference. Okay, so I hope you understand what I'm talking about and what is a pattern, right? To sum up, a pattern is a consistent and recurring characteristic. Okay, it repeats itself in a recognizable way. Okay, so it could be numbers, it could be images, it could be alphabets, it could be designs, anything. Okay, so first we will see a pattern that occurs in our everyday life. uh, how even kids can recognize patterns. Then we will go into how pattern recognition is used in artificial intelligence. Okay, how pattern recognition is helpful in solving some of the complex problems, right, facing mankind, facing businesses. Okay, and and towards the end we will see some examples and where you can participate, you can identify patterns. Okay, and you can also test how good you are in identifying patterns. So that's what we are going to see in today's session. Okay, as I said, pattern recognition can be seen everywhere. Okay, it is there in nature as well, right? It's there in the days of the week. The days of the week get repeated after every 7 days, right? Monday, and after 7 days, Monday comes again. Tuesday, the same thing, right? The months come after the same month, January. The next January comes after 12 months. It's a repeating and consistent characteristic, right? The same thing is seen in nature also, right? The pattern is there in nature. As you can see here in this leaf, there are patterns that are consistent, right? And they are repeated. The one that you see above is what is called as Fibonacci series, right? This is something, what is called as the golden ratio that gets repeated and is seen in many animals and plant forms and the way animals group themselves. Okay, this is an important concept, right? Fibonacci series. I'm not going into the details of what is a Fibonacci series. Okay, it's the way the numbers get repeated. Okay, and we can see this mathematical series of numbers, right? What is called as the golden ratio get repeated in different animals, different plants, in different groupings of even small insects, right? So that's why I say that pattern is there in nature, right? So next time when you go for a walk, when you're driving a vehicle, or talking to your friend, look for patterns. Patterns in individuals, patterns in your surroundings, patterns in plants, pattern, in small, pets like dogs and everything, right? So cultivate this habit of looking for patterns. As machine learning and artificial intelligence professional, that's what you're going to be doing, right? You're going to be identifying patterns and you're going to make computer or software learn pattern recognition, right? So cultivate that habit. Some are good at it, right? And it's something that you can definitely improve over time. Okay, so as I said, pattern recognition is at the core. Patterns are there everywhere. They are in plants, they are in animals, they are in insects, they are in environment, they are in clouds, okay, everywhere. Pattern is there everywhere, right? We have to identify, right? Some people are good at spotting patterns, right? Which is why we say that, let's say your friend, okay, he always comes to the class wearing a blue shirt, right? One day when he comes wearing a white shirt, you recognize, hey, you're not following the pattern. You normally come wearing a blue shirt. Today you're wearing a white shirt, right? That's a pattern and something that doesn't fit into the pattern. Okay, what is called as an outlier or anomaly. We are going to see outliers and anomaly, in subsequent sessions, right? All of that, right? Patterns, outliers, anomalies, they are used in solving business problems, in solving problems facing mankind, like health problems, right? So pattern recognition is at the core, and patterns can be seen everywhere. And pattern is a consistent, repeatable characteristic, right? That's what you have to understand. Okay. Do you know that a child can recognize familiar faces at the seventh month itself, right? Just a 7 month old baby can recognize the faces, right? Which is why when unfamiliar faces are there, it actually cries, right? So, have you seen that? Next time when you see a baby, observe this. If you're familiar to the baby will smile, okay, make gestures. But if you're not familiar to the baby will cry. Why? Because if the baby cries on seeing you, it means that you don't fit into the pattern that the baby has learned, right? If the baby smiles on seeing you, it means that the baby recognizes the pattern, right? Because you're a familiar face. It's a pattern. When it cries, it means it's an unfamiliar pattern. And as you can notice, child can recognize, by seventh month, or in some kids, right? In today's kids, it can happen much earlier too, right? So pattern recognition is an important trait, right? Is an important developmental activity of a child. And people with some problems, right? Some mental problems or psychological problems, they are usually challenged to identify patterns, right? That's why I said it's an important developmental characteristic in a child. Okay, and the caveman, right? The caveman has used patterns to identify dangers, right? Whenever any danger is there, for the caveman, which invariably calls for, the caveman having to run or fight, the flight or fight, right? That we're talking about. The flight or fight decisions are made by the caveman based on patterns. If it is something that, caveman can manage, right? It's going to fight. Can't manage, is going to run, right? So the decision of whether to fight, or to run away is based on patterns. If caveman had not perfected this characteristic, right, he would not have survived. He has survived because he has perfected this characteristic of identifying patterns, right? Why I'm talking about all this is pattern recognition is at the core of who we are, right? It's at the core. And it's at the very core of artificial intelligence, right? As I said, artificial intelligence is about our attempt to make computer software behave like humans, right? So this characteristic is there in all of us and is at the core of who we are, right? The child can recognize, the caveman recognized it, right? And used it to forewarn himself, right, of dangers, and used to decide on the actions he is going to take, in terms of managing the danger that has come, to him. And we are identifying patterns all the time, right? When we identify friends, when we like someone, it is based on certain patterns. When we don't like someone, it is again based on certain patterns, right? So it's part of us, right? And often we do it intuitively, which means, we do it without we ourselves knowing it, right? So it's become kind of our nature, right? To spot patterns in things around us, in faces around us, in people around us, in activities around us. So this is a very, very core thing, which is why I said, in child, uh, pattern recognition or pattern distinction is an important developmental characteristic, right? It's at the core of who we are as human beings, right? And in artificial intelligence and machine learning, everything revolves around pattern recognition, right? Which is why we are covering this topic in this session. Let's move on, right? As I said, all learning comes from patterns and identifying patterns, right? It's a massive hierarchical recursive process taking place in the brain, right? Everything happening from the process of identifying patterns. See, even in the case of reading, right? Let's say you're reading a book, right? First, you recognize the patterns of individual letters. That's how you start, right? Then you identify the pattern of individual words, right? Start with letters, then individual words, right? Then groups of words together, okay? Maybe a sentence, right? Then we are talking of paragraphs, then entire chapter, and then books, okay? So everything starts from identifying patterns. As I said, we are doing it intuitively, right? It has become our nature to identify patterns. It's not like someone has to nudge us or prod us, say, hey, go and identify patterns. No, we do it ourselves. We do it intuitively. We do it without anyone telling us. And sometimes, rather most of the times, we do it without we even aware of this activity. Okay. And coming back to the reading example, once a computer can recognize all of these patterns, it can read, right? And more importantly, learn, right? This is how you're going to teach the computer. If you have to teach the computer, right, the learning process, you have to first make the computer or the software recognize the patterns in individual letters, then the patterns in individual words, then the patterns in sentences, then paragraphs, then the chapter, and then the book, right? That's how the computer, right, or the software learns, right? Learns the process of reading. So when you create an application for something to be read, right, the software is then successful in doing this activity. Okay, so that's on learning, as I said, as fundamental as learning, and that's what happens. Something similar happens in other types of human activity, right? Like thinking, like taking a decision, like predicting, right? It follows from identifying patterns. So you teach the computer, okay, teach the computer or the software to recognize these patterns. And once the pattern is recognized, you're going to make the computer decide what it wants to do, right? Based on the objective. First is pattern recognition, and then whatever action we want, we then program the computer or the software. So that's what happens in pattern recognition and machine learning. Okay. In the previous session, we saw driverless cars, right? The cars are driven without drivers. Right? So before seeing that, let's understand about going to work on time, right? Or going to school or going to college, right? It is a result of recognizing patterns in your daily commute, right? And responding to changes in schedule and traffic. Going to office or to school or to college, right, is the result of identifying patterns in your daily commute, the way you go to your school, college, or office, right? What are the patterns? Certain routes will have some traffic snarl on certain days, right? Certain roads will be free on certain days, right? So you need to know the patterns. And suddenly, if there is a traffic jam in one of the roads that you normally take, what is going to be your alternate path? So you know that, right? So intuitively, you know. So which is why when you're driving or let's say cycling to school, when you see pile up of traffic, you know what to do, right? So it's become second nature to us. It's become intuitive. So we know the pattern, right? If something is obstructing, we know what to do, right? So we are kind of expecting this to happen. If something like this happen, if there is a block, I know what to do, right? I know the pattern to follow. That's what happens in getting to work, right? Or going to school or going to college, right? So it's a series of patterns, even in your daily commute. So next time, or even tomorrow, or even today, if you're going to work or school or college, look for patterns. Look for patterns on your route. Okay, you will be amazed at how many patterns you have identified and how you have identified without anyone telling you to do. That's the beauty here, right? It's become second nature. We are intuitive at it, right? So when somebody has to design a driverless car, right? All these patterns, right? Traffic and schedule changes, and all of this have to be understood by the car. If somebody comes in front of the vehicle, you are applying a brake, right? That's a pattern. This is a pattern that you have to teach your driverless car system, right? So all the changes, all the traffic challenges, everything, the driverless car system is able to learn from patterns. So if you're designing a driverless car system, from your experience or others' experience, you're going to document the patterns and you're going to teach those patterns, right? You're going to make the software, make the system learn those patterns. In the case of driverless car, right? It's a fabulous example of artificial intelligence, right? If the car doesn't stop in front of someone, it can result in an accident. So it becomes important that pattern recognition is comprehensive, is thorough, right? Because if you miss some patterns, it can be costly, right? And you cannot teach all the patterns to the computer, right? So the computer is taught how to identify patterns. So the system learns to identify patterns based on your commute. The system automatically does, and it self improves over time. That's where artificial intelligence comes in, right? So to sum up, in the case of driverless car, right, it's related to patterns that are there in our commute. Could be commute to office, commute to home, or commute to your school or college, right? There are patterns everywhere. And if you were to design a driverless car, you have to teach the system to learn to identify these patterns. And some of the patterns you're going to provide as inputs as well, right? And you are teaching the computer to learn from those patterns, right? So pattern recognition is at the core of artificial intelligence, right? Let's see some more examples. Pattern recognition is there in disease prediction also. Suppose if someone is having high cholesterol, high BP, and high sugar, probably a fit candidate for stroke or heart disease, right? Someone having high BP, high sugar, high cholesterol, then that person is more likely to have a heart attack down the road, right? So that's a pattern. The pattern is identified by analyzing the history of patients who have suffered a heart attack or stroke. And those patients had high BP, high cholesterol, and high sugar. Hence, any patient who exhibits high BP, high cholesterol, or high sugar, right? Combination of three that I'm talking about, these three factors, is more likely to develop a heart disease in future. See how we are identifying patterns. First is pattern identification, and then we use the patterns, okay, to predict. That's what you as artificial intelligence professionals are going to do. In loan defaulter, let's say you take a loan, right? Say a home loan. After some time, you stop paying the loan. That is a loss to the bank because you are a defaulter. You are not repaying the loan. That is something the banks don't want. In fact, the banks want to know ahead of time who is likely to be a defaulter. Once they know who is a defaulter, they can then go and take actions. They can go and take proactive actions. See how artificial intelligence is helping to solve business problems. In the case of banking scenario, the bankers would like to know which of their customers are likely to default in loans. So they can go and take proactive action. They can go follow up with that customer. They can ask, are you going to pay this month? Do you need any help? Or any other insights could be gathered by the banker and appropriate decisions could be taken. For this, also the pattern recognition is there. Patterns of defaulters are analyzed, right? And then the patterns, or rather the factors that contribute to defaulters, are fed into the system to identify future defaulters. The software or the system is able to even analyze hundreds of factors. Factors like age, job, level of education, whether that person has got a working spouse, amount of loan, like this, hundreds of factors. Each one is a factor, okay? Like age, education, like this, hundreds of factors, okay, can be analyzed by the system to identify patterns. If it is a simple case of identifying, say, odd number in a series, that is easily done by humans, right? But if it is a complex system, which is what is the case in real life scenarios, in the banking example that I talked about, in the healthcare example that I talked about, there are multiple factors. It is impossible for humans to identify patterns when the complexity increases. When the complexity is very less, when it is a simple scenario, human beings can identify patterns easily. When the complexity increases, which is what happens in real life scenarios, human beings cannot identify patterns. That is where machine learning comes. The software will identify patterns and decides what are the characteristics of a defaulter. It uses that learning to predict for the future, to predict occurrence of disease, to predict who is going to be a loan defaulter. Can you see now how it all fits in? How pattern recognition helps to solve business problems? How machine learning uses pattern recognition, right? Let me explain this once more. If it is a simple scenario, you're going to see some of the examples, right? If it is a simple scenario like identifying patterns in the number from 1 to 10, right? You see odd numbers, you see even numbers. That's a simple pattern, right? Human mind using human eyes can identify patterns, right? When the complexity increases, when the number of factors are more, can the human mind decipher the patterns? The answer is no. That is where machine learning comes. You're going to write software that can identify patterns, and you're helping the computer to identify the patterns. Once it identifies the patterns, it uses the characteristics that form the basis of the pattern to identify, rather to predict for the future. So that's what happens in machine learning. Your software identifies the pattern. 2, it identifies characteristics of a pattern. 3, uses the characteristics that it has identified From the patterns it has observed in the data set or in historical data, it uses that to predict for the future. That's how diseases are predicted. That's how loan defaulters are predicted. See, this is a wealth of information, right? For any business person, for a doctor, for even for an ordinary human being. If you know that you're likely to develop a particular type of disease, you can then go and take action, right? And in machine learning, the software improvises the process of identifying patterns. It fine tunes and refines over time. That's the added benefit. And because it is done by the computer, even if you feed historical data right at the middle of the night, it can spot patterns, which is not possible by humans at all, right? If you're feeling sleepy or if you're tired, if you're not eaten, can you identify a pattern? No, right? Cannot identify a pattern because you want to either eat or take rest, right? Or go to sleep. Here we are talking of a machine or a software. It works 24/7. It works on holidays, right? Which is why I said this pattern recognition and machine learning is used to identify even fraud on a proactive basis. Sometimes we get calls from banks at odd times, on weekends, on holidays, asking us, have you done this transaction? Have any of you got such a call? It means probably your banking account is compromised. Some suspicious activity happened. It's all identified by machine learning algorithms, right? So the bank is warning you. The bank has actually stopped a suspicious transaction. Once you validate it, right, either it is a genuine or not genuine, accordingly the bank will take the uh, respective or the appropriate action, right? So pattern recognition helps in forecasting, right, which is a very, very useful thing for businesses to have, for medical professionals to have, for ordinary people to have. Let's say you are a student. If I can predict, right, based on the patterns, right, that you are going to score certain marks, you probably are going to take some action, right? So that's the beauty of pattern recognition. That's how helpful pattern recognition is in machine learning. Do you understand it? Okay. So let's move on. Patterns in forecasting. This is also something you should know. Forecasting is one of the fundamental things we do in artificial intelligence. Forecasting for the future. This number, this graph that is there in your screen corresponds to sales figures, right, of different time frame, right, 2010 to 2015. If you see, there is a spike somewhere around July, and there is a drop somewhere around Jan, and this gets repeated every year, right? So this is a pattern, right? Every July there is a peak, and every January there is a trough, there is a bottom, right? This is the lowest point and this is the highest point for this particular year, and this gets repeated every year. So if you forecast for next year, say 2016, what will you say? You will say January 16 will be low and July 16 will be high. And if you see the increase between this, it is also nearly proportional. So that is also something you will say, right? And this is something that you can do with your naked eye, right? If, let's say, I introduce additional factors or ask you to consider 100 years of data and then forecast, do you think you will be able to do just by observing with your eyes? The answer is no. There you have to use some software to identify these patterns. Okay, this is actually called a seasonality in forecasting, we are having a separate session on forecasting where we will cover this in more detail. Okay, we call this process, we call this phenomenon, the pattern that you're seeing, as seasonality. As I said earlier, the sales typically peak during Christmas time frame, right? And then it drops. Christmas, New Year time frame, you see sales increasing. Diwali in India, the sales increase. Or Chinese New Year in Southeast Asia, right? The sales typically increase. And then it drops. As people, as artificial intelligence professionals working on forecasting systems, it's important that you identify the patterns in your data. If you don't identify the patterns, what happens? You are going to make a wrong forecast. And if you make a wrong forecast, what will happen? You are, let's say you are responsible for stocking shirts. Okay, you are responsible for ordering shirts in a showroom, right? If you don't know the forecast, or if you make a wrong forecast, you will either stock more shirts or less shirts. If there are less shirts, people are not going to buy. They will go to some other shop and buy. In both the scenarios, there is a revenue loss, right? You understock or overstock, there is a financial impact. A wrong forecast is leading to an adverse financial impact. This could have been avoided if you had identified patterns. In the example that I mentioned, the shirt, right? What are the different factors? You're talking of different colors, you're talking of different size, you're talking of different cut, talking of different fit, right? Like a slim fit or a casual fit, right? Four factors, right? Minimum of four factors: color, size, fit, size, right? Four factors, or more factors can also be introduced. If you have to incorporate all these forecasts, all these factors, and do your forecasting, can you do it just by using a paper and a pen, or even using Excel, Microsoft Excel? The answer is no. You need a forecasting software. You need a forecasting software to identify patterns. You should know what is the in thing, right? In shares. So you can make right decisions in stocking. Without those forecasting inputs, you will end up making wrong decisions which lead to an adverse financial impact, right? So forecasting is an important aspect. Okay, in fact, that's at the core of what we do in machine learning, right? It's one of the fundamental examples, right? Forecasting for the future, forecasting future numbers. It is like forecasting how much marks you will score in an exam based on your past performance, right? That I can do a forecasting. So this is one of the fundamental examples. Forecasting for future, forecasting the future demand, right, is a fundamental application area of machine learning. Okay, and there, by using software, machine learning software, you will be able to spot trends which your human eye cannot spot. Because when factors and complexity increases, humans cannot identify patterns inherent in the data, and they will end up making wrong decisions. In the example that I cited, there is an adverse financial impact because the patterns were not identified correctly. So the forecasting went for a toss, right? Their forecast accuracy is bad. So I hope you now understand the importance of pattern recognition. The importance of pattern recognition in solving problems. If you don't identify the patterns clearly and correctly, you make mistakes in forecasting for the future. As I said, If it is a simple case, right, like what you see in your screen, human eyes can easily identify the patterns and even tell what the future is going to be. If the complexity increases, if the number of data points increases, like I said, if you're going to take 100 years, as the basis to forecast for the future, right, the complexity is increasing. Human eye cannot do this forecasting, right? You cannot do this with a pen and paper or even using things like, Excel sheets, Microsoft Excel. You have to develop the software. It has to be a machine learning software because the complexity is high, because the number of factors are more, because you have to factor in everything in determining the future demand. But at the core, it's about identifying patterns. We are using software, machine learning software, to address the complexity that is inherent in the data. So the software will learn the patterns that is there in the historical data, will use that learning to predict for the future. Because our objective is to solve a business problem, right? In this case, I must know what the future demand is going to be, so I can take right forecasting decisions, whether it is stocking, right, or it is uh, ordering for something, or it can be any forecasting need. So do you understand? Do you all understand how important pattern recognition is? Without pattern recognition, there's no machine learning. And as I said, we are going to see this uh, patterns in forecasting when we come to the forecasting session. Regression, right? This pattern that you see on your screen is called seasonality. You will see that in more detail when we cover regression. Okay, so we saw a lot about patterns, right? We saw pattern is at the core of machine learning. Pattern is a repeatable something, is it gets repeated. We saw patterns being present in nature. Uh, we also saw patterns used to solve some of the business problems, right? Pattern identification in the case of loan defaulter or disease prediction, right? Or even driverless car. The core is about identifying patterns, right? So that's what we saw. So let's take some examples, right, and see how pattern recognition works, right? So let's see some simple examples, and then we will also take a moderately difficult task and see how you perform. Okay, fine. So you are saying 1, 3, 5, 7. What are the next two numbers? In fact, I have given a clue in your screen. These are consecutive odd numbers, right? There seems to be a pattern, right? All of you can see a pattern, right? 1, 3, 5, 7. It's consecutive odd numbers. Nothing else. Simple pattern, right? So what are the next two numbers? What are the next two numbers? I think you would have guessed it. As I said earlier, if it is a simple one, you can do it manually, you can do it intuitively, you can do it in a matter of seconds. If the complexity increases, it takes time. And in many cases, you have to write a software. I don't think you need a software for this, because the answer is 9 and 11. Very, very simple example, right? Dumb example. Do you say that? You think so? Very, very simple example. I can hear the murmurs. Okay, it's a very simple example. There's no rocket science, right? Because 1, 3, 5, 7, the next two numbers are 9 and 11, because it is consecutive odd numbers. I can also hear we don't want such simple examples or simple tests. Bring it on. Okay, I hear you. I hear you. So I'll give you this. Can you identify the pattern? Take your time. Take your time. You say it is A. Okay, that's a pattern. But is that the only one? See carefully. Take your time. In the previous one, that was an easy one, right? Many of you, uh, many of you could do it in a second, or a couple of seconds maybe. But this is taking time, right? This is taking more time than you thought. This is taking more time. CA? No. In fact, C appears only once in this. In fact, C can be even considered as an outlier, right? Anything that doesn't fit into the pattern is called as an outlier. So C can be even called as an outlier. I'm asking you to recognize a pattern. Okay, okay. So what could be the pattern? What could be the pattern? AAB, you're almost there. You're almost there. Spend a little more time. You can identify the pattern. Okay, in 10 seconds, I'm going to show the answer. Just 10 seconds. See if you can recognize. Imagine if it is more complex. If there are thousands of lines like that, can you identify? No, you cannot identify. You need a computer software. The pattern is AABA. Okay, now quickly, just take a minute. How many times this pattern can be seen in this text? You only have a minute. You only have a minute. In fact, it's less than a minute now. Quick, make it fast. How many times this pattern is getting repeated? AABA. 4 times? No, I don't think so. Twice? Okay. Check once again. You have less than 30 seconds. I'm going to reveal it. Few of you might have got it. Some of you. I think I'm giving more time, is it? I can hear you. I can hear you. So this pattern AABA is getting repeated 3 times. Can you see it? It's getting repeated 3 times. AABA, AABA, AABA. Did anyone get this right? Okay. So can you see? The first one is an easy one, right? This one is slightly difficult. Slightly difficult. You have to put in more effort. As I said, if there are hundreds of lines, can you spot a pattern? There can be more than one patterns, right? In a data set, there can be more than one pattern. If you are talking of a very complex one, there can be even tens or twenties of patterns. You have to consider all of that in determining the forecasting, in determining the future business approach. So for all of that, you need to use machine learning, right? That's where the process of teaching the computer to identify pattern comes. Can you all see it? So there are three patterns, three repetitions. Sorry, the pattern of AABA gets repeated 3 times in this text. Okay, so let's see one more example, right? Can you see this here? If you see this, this is all the same letter, right? 1. But is the pattern same? It's all same letter, but is the pattern same? I here, yes. Do you think so? What about 2? Is the pattern same? What about 3? Is the pattern same? Well, the answer is no. The pattern is not same. The pattern is different. Probably the pattern is the same in this. Pattern is the same in this. Pattern is the same in this. But if you considered horizontally, it's not forming a pattern. These are 3 distinct things. Because here there is no, this protrusion is not there. The protrusion is happening actually in the second row and in the last row. Right? So this is not a pattern. Whereas this is a pattern because there is no protrusion. See, there is a protrusion here. There is a protrusion here. Here the type of protrusion is different. But same in this vertical, in this third column. If I call this as column 1, column 2 and column 3, this is all one type of pattern. This is all one type of pattern. This is all one type of pattern. But across the pattern is different. Though it is just number 1, the computer will not treat this as a same pattern. Understand this. The same thing applies here as well. Because what it does, based on the different things that it sees, it identifies a common one, right? That is kind of representative of this entire data set, right? How it comes to this is by identifying patterns. The underlying theme, the defining characteristic is this is green, this is yellow, maybe dark yellow, right? Whereas in this it is this pattern. Can you see it? Okay. Sometimes it is based on color, sometimes it is based on this characteristic, right? Sometimes it is even based on this protrusion. This is how the computer will learn the patterns. The way the humans identify patterns may be different, right? Because it depends on the way we have been taught to identify patterns very early in our lives, right? The way we study different subjects, the way we were brought up, the culture, all those things will determine how you identify a pattern. Whereas the computer, no, it doesn't work that way. The computer will look for the dominant characteristic, right? Or dominant characteristics. It can be one or it can be multiple, and then it identifies a pattern. Do you understand? So this is how the computer will work, and the way we work slightly different, right? But at the core, we are trying to teach the computer or software to learn the process of identifying patterns, because once that happens, we can then determine the future. We can then forecast for the future, which can be used for prediction, which can be used for taking decisions in the business, or in the case of disease prediction, what type of medicines to do, what kind of lifestyle changes that have to be made. All those decisions can be made on the forecast or the prediction, and all of that is done using patterns. Okay, I hope you enjoyed today's session, right, on pattern recognition. Before I close, uh, let me just answer one question that I normally receive from students, in the area of pattern recognition. People ask me, is it possible, right? If let's say, is it possible for me to improve, right? That is possible for you to improve the way you recognize patterns. Yes, I will say, a resounding yes, I will say, because you can definitely improve the way you identify patterns, right? Become more observant, when you go out, when you talk to friends, right? When you are in the midst of people or when you see animals, look for patterns, make an effort. It's a wonderful characteristic to have, right? In fact, it can be an advantage, right? If you identify patterns, you can distinguish things easily, right? So it is very much possible to improve one's one's prowess in identifying and recognizing patterns. It is very much doable, and as I said, it's something can be an advantage to you. Okay, so that's all for this session. I will see you again another session. Thank you.